the standard forms of a hyperbola. Okay. Just like the pattern has been, we are going to work backwards with our information to write the equation of our hyperbolas, okay? So there are three things we need to know about our hyperbola in order to be able to write the standard form equation. What are they?
A and B.
We need A and B
Center.
and the center. If we know those three things, then we can write our equation. Now, we're not always going to know A and B specifically. They could give us information about C, and we have to find A or B with that. Okay. We'll just have to see what we get and go from there. So you guys are going to help me out. Okay? This is what we know. We know that the vertices are at plus or minus 4, 0, and the foci are at plus or minus 6, 0. Okay? Let's see, Matt. Tell me one thing that we can take away from this.
The center.
The center's probably at the origin, and why do you think that?
Because the vertices are equal to this.
Hey, what do you think about Matt's logic? Sounds good? Okay. Something else. Michael, what else can we take away from this?
Find A.
All right, and what is that?
4.
And why do you say 4?
Because the vertices are 4, 0.
Okay, the vertices are at 4, 0. Our center's at 0, 0. Do you guys agree with Michael? Sound good? All right. Amanda, something else.
C is 6.
And why do you say C is 6?
Because the foci is that far away from the center.
The foci is that far away from the center. Excellent. So we've talked about the vertices, we've talked about the foci. I think we've picked everything out of this picture that we can, right? Oh, no, we haven't. There's one more thing we need to identify.
B.
We do need to find B, but before we do any calculations,
I open horizontally.
okay, we need to identify that it is a horizontal hyperbola, so we know which standard form to put all this information in. And then, yes, Sean, we're going to need to calculate B. All right? So, standard form equation, x minus h squared and y minus k squared. X has to be the positive one because it is a horizontal hyperbola. Okay, we've identified our center to be at 0, 0. So we have x minus 0 squared and y minus 0 squared. And we've identified a to be 4. So a squared is going to be 16. All right, Grant, how can we find b?
C squared equals A squared plus B squared.
Okay, so we know c is 6 and a is 4. So what does that make b squared? Do we really have to go all the way and solve for b?
Yeah.
We're looking for b squared to plug in. If you solve for b, not a problem. But I'm just going to go ahead and save myself some work and just plug in b squared. That is the equation of that hyperbola. This feels very familiar. I mean, this is almost identical to the problem we looked at on Thursday for ellipses. Do you agree? Okay. Next problem. we have the points -2, 1, and 2, 1. Those are vertices. And we know it goes through the point 5, 4. Okay. Cassie, what is one thing we know about this picture? The center is at 0, 1. Do we agree with Cassie? All right. Maggie, why is it at 0, 1?
Because it's in the middle of the two vertices.
Okay, right in the middle of the 2 vertices. Great. Brianna, what's something else we can pick out? A equals 2. We have our vertices, we identified our center, so now we can say that A is 2. See, Maddie, is there anything else that we can pick out?
Can't you plug in 5, 4 to find?
Okay, so since they gave us a point, we can plug it in to help us find something. Okay, that is a good thing. And before we do that, we'll need to write our equation down, but I need to know how to write it. Sean?
It's horizontal.
Okay, we need to say that it's horizontal so we know how to write the equation. So, horizontal, we're going to have x minus 0 squared over a squared minus y minus 1 squared over b squared equals 1. Okay? We know a is 2, so a squared can become 4. Okay? So then Maddie suggested we plug in a point to figure out what b squared is. Is that our only option? How did we find b squared over here? We use c. Do we know anything about the foci in this problem? We do not. Okay, but we're stuck with a b squared in there. So what we can do, and I'm going to go ahead and write this as x squared if that's okay with you. We know that 5, 4 satisfies our equation, so we can plug it in and solve for b squared. So let's do that. Our point was 5, 4, so we can plug 5 in for x and 4 in for y. So we have 25/4 minus 9 over b squared equals 1. Help me out. What do we need to do?
Cross multiply.
I don't know. What do you guys think? Cross multiply. Can we do that? Okay, so you're seeing the big picture. Eventually we're going to need to cross multiply, but then you decided maybe we should. Okay. Which number should we take over to the other side? Okay, so if we add this over, we're going to be in the same pickle, right? We're going to have two different terms. So let's subtract this over. So what is 1 minus 25/4?
Or, yeah.
Negative 1? What did you say? Oh. I thought you said 51. I couldn't hear you. Alright. Now, what do we do with the proportion? Cross multiply. So I'm going to come over here. When we cross multiply, we have essentially negative 36 equals negative 21b squared. Right? So b squared equals 36 over 21. It's kind of a gross number, right? Is it bad? Because it's a fraction, are we wrong? Well, you can square both sides to solve for b, but in our equation, we want to write b squared, so you might as well just stop here.
But I meant like, so it'd be like,
Oh, yeah. So what would it be? 12/7? Okay, great. So then our standard form equation would be x squared over 4 minus y minus 1 squared over 12/7 equals 1. Now, typically, do I like fractions in a fraction? Typically, I do not. However, in this case, I like to be able to identify A and B, and so I am okay if you write fractions in your denominators when you have the standard form of an ellipse or hyperbolas, because then it's easier to identify A and B. All right, I'm going to give you a couple minutes to think through this problem. I want to see what you can do here. And work together in your pods. This one's a little different than ones that we've seen. All right, let's come together. I'm seeing some really good stuff. Here are our vertices, right? and then y equals 2/3 x. Is this, right? And then 4 minus 2/3 x. 4 minus 2. Looks like that, right? Okay. So someone from pod 1, tell me something that we can take away from this picture.
The center is at 3, 2.
The center is at 3, 2. Oh. Do we agree with pod 1? The center is at 3, 2. Smack dab in the middle of those vertices. The center's at 3, 2. Pod 2. What else?
It is 2.
A is 2. Can you defend your answer?
Because that's how far the vertices are away from the center.
Excellent. Pod 3.
It's a vertical.
And how do you know that, Sarah? Okay, so the vertices are vertical from the center. Excellent. So I'm going to go ahead and write y minus 3 squared over a squared minus x minus 2 squared over b squared equals 1. Oh, and we know that a is 2, right? So a squared is 4. All right, so pod 4. What did you do with those asymptotes?
Plotted them to make a rectangle.
Oh, so you did this? Excellent. And then what?
That gives us b of 3.
Okay, so since this was 2, that was A, and so you measured this distance right here, and that was 3, so you're saying B is 3. Yes.
Wouldn't it be water minus 2?
Very good. Look who's paying attention. What is the mistake that I made? I just wrote them in order, right? My center's 3, 2, so I'm going to put 3 here, 2 here. That is wrong. Thank you, Siobhan, for raising your hand. This should be 2 and 3. Okay? That is a mistake. That is very easy to make because you want to put things in order, right? Especially with hyperbolas. In ellipses, we always write the x squared first and the y squared second. With hyperbolas, sometimes the y squared comes first, and so you want to fill things in like that. Okay? So b is 3, which means b squared is 9. Yes.
What is our c?
In this one?
Well, no, just thinking in general. Like, what does it mean?
Okay, our C value is always how far away our foci are from the center. Okay, with both hyperbolas and ellipses, that's how far the foci are. And A is always how far away the vertices are. Okay. Any other questions? Is this helping those of us who were maybe a little behind the game on Friday, or didn't look at our homework very much over the weekend? Just helping bring it back a little bit. Okay. Something else you're going to have to do in your homework is identify the different types of conics based on their general equation. Okay. So here I have 4 general equations, and I need to figure out which ones are circles, parabolas, ellipses, and hyperbolas. All right? So let's see. Do you want to start with number 1? Sure. Grand Gops, what's number 1?
Eclipse.
And why do you think that it's an ellipse?
Because it's x squared plus y squared.
Okay, so we have x squared and y squared, and it's adding instead of subtracting. What do you think about his logic? Sound good? I like it. All right. What about number 2? Let's see, Nate. What do you think about number 2? And why do you say parabola? Because only one variable is a square. All right, what do you guys think? Yeah, I like it. Now, since it's y that's squared, what kind of parabola is it going to be? What? It's going to open either right or left, right? Great. What about number 3? Sean, what do you think?
Ellipse,
And why do you think it's an ellipse?
because it's an addition. It's addition between x squared and y squared.
Okay. I'm going to tell you, if this was your answer on your quiz, you would only get half credit. Why?
Because there's -3.
And what does that have to do with our ellipse?
So that means that when we complete the square, we can probably change some variable.
Okay, this is true. This is true. But that would happen in number 1 as well, wouldn't it? Okay. Why would I only give you partial credit for this? What's true about the coefficients of x squared and y squared? Okay. They are 1. What's important is that they are the same. Okay? What's going to happen once we complete the square and we divide by what's over on the other side? If these two have the same coefficients, what's going to be true about when we divide? Okay? Since those coefficients are the same, A and B, when we divide things over, A and B are going to be the same. Do you believe me, or do we need to work that out so you can see it? You believe me? Yes.
So if x and y are squared and have the same coefficient, all of it is equal.
Yes. And then number 4. What is number 4? Cassie. All right. And why a hyperbola? Okay, so we have x squared and y squared, but one's negative. Excellent. So in order to earn your homework today, I have an activity for you.
What if we don't earn it? Can we get it?
You'll get it. Okay, what I'm going to do is I'm going to